Moment of a couple, topic 4.6. Moment of a couple. Today's objective is to learn how to define a couple and determine the moment of a couple. In statics, in engineering mechanics, couple is when there are two forces which have equal magnitude but opposite direction. And then these two forces, they form a couple. So in statics, a couple is defined as blank separated by perpendicular distance. Two forces of equal magnitude acting in opposite direction. So this is the correct answer. The moment of a couple is called free vector. We will learn about that in the presentation. Applications. In this wheel, force F is applied by both hands. This hand pulls the wheel and this hand pushes the wheel. So this is 30 Newton, and the perpendicular distance between two forces is 0.4. So the couple moment is multiplication of 30 times 0.4, and that's the couple moment that is being applied here. In the second example, the distance between them is now 0.3 and the amount of force is 40 Newton, so it's 40 times 0.3. So you can see that as the distance between the perpendicular distance between the couple forces decreases, we need to apply the more force in order to get the same torque or same moment. When you grip a vehicle steering wheel with both hands and turn, a couple moment is applied to the wheel. So one hand is pushing, the other hand is pulling, and there is perpendicular distance between them, d, and that applies the couple moment. Would older vehicles without power steering have needed larger or smaller steering wheels? So if you compare cars from 1970s and 80s, you will notice that they had bigger steering wheels compared to modern day cars. And one of the reasons they had bigger steering wheel is that they use mechanical system to turn the steering wheel, and that required large amount of torque. Now to reduce the amount of force required by the driver, the size of the steering wheel was increased. That means it had larger diameter to reduce the amount of efforts or force to have the same couple moment. However, that's not the case with modern cars, because modern cars uses hydraulic system and power steering. So even with small amount of force, we are not actually applying that force directly to the wheel, but we are simply controlling the hydraulic system, which in turn amplifies and applies the high force. The equation for the moment of a couple in two dimension is F times D. That's the scalar analysis approach. And for vector, it's R cross F, where D is the distance between two parallel forces in two dimension, and R is the position vector between two forces in three dimension. Now the couple is also called the free vector in the sense that we can slide the couple without uh, changing the effect the couple that has on the system. For example, there is in this pipe assembly one couple moment. This is how we indicate the couple moment in the system, by an arrow. So when we have a force, we draw F, but when we have couple moment, we do this. So there are two couple moments M1 and M2 applied at two different joints on the pipe. But since the couple is a free vector, to find the resultant couple moment on the pipe assembly, we can slide them. So see, there is a gap here between them, but we can actually move this up or move this down and bring them at the same point, and then find out the resultant couple moment, very similar to how we find the resultant force by vector addition of moment 1 plus moment 2. So MR can be calculated as M1 plus M2 in this case. Okay, and that's why it's called free vector, because we can move this around. And in the next video, we will solve a problem involving couple moment.